Hello, my name is Dr. Ved Prakash and I am the Research Imaging Specialist in the Imaging Core Facility at University of Texas, Dallas. Today we'll be discussing about which microscope is the suitable one for your sample and what kind of imaging methodology could be giving you the result that you are looking for. We have several different varieties of microscope in our facility. Currently we have 5 different microscopes. Number one is the standard laser scanning confocal microscope from Olympus, which has got a capacity to image at a very high resolution with a very high flexibility. Second one is a spinning disk microscope, which can do high speed imaging in a very large field, even at a very high resolution, and it has got a capacity to do super resolution imaging as well. Third one is a slide scanner microscope. It's like an automated workhorse for imaging large amount of slides. Fourth one is a total internal reflection fluorescence microscope, specifically designed to image near the surface of the cell or do a single molecule analysis. And the fifth one is a twin laser multiphoton microscope designed specially for doing intravital imaging in mouse, as well as do photo activation and scanning simultaneously. These microscopes are very powerful in their own ways, and they also have their own limitation. So a few examples of the images acquired by some of our users are here. They are really amazing and beautiful images and have a lot of information content, and I highly applaud them for this amazing job. Now the question comes for you as a user or a brand new user. How do I acquire these beautiful images? And how do I even design my experiment, whether is this microscope good or is this microscope good for my experiment? What kind of image analysis protocol would you use? Whom do you ask those questions? So I will be taking you through a small journey which will help you understand the philosophy that I personally take to make my decisions. For example, if you want to start from Dallas and you want to go to Chicago, how do you do that? You first of all put the destination in the Google Maps, and it gives out possible options that okay, you can take a car or you can take a flight or you can walk all the way or figure out right. Same way, in the real life, in the case of microscopy, you have to understand what kind of real and final image you would like to have, what kind of result that you would like to have, and then ask from a Google map, basically me or your senior who has already done the experiment, or some paper which has already showed that the experiment works, and then figure out which microscope they have used or which is the best one that can give you the result that you want. Depending upon the amount of time that you have, the kind of resources that you have, the amount of effort that you want to put in, things like that. Sometimes we have a tendency to fall in love with the vehicle because we are comfortable doing that. Like in this case, if you are comfortable taking this car, you would say, oh, I love driving, and you will try to justify, give all the reasons that why you should take a car and not a flight, even though it is going to save so much of time and effort, because it is something new to learn, or is it's something uncomfortable initially, but if you get used to it, eventually it can become comfortable, right? In this case, you can take either of the vehicles, but in a case where you have to take a long distance journey, like flying from Dallas to India, the only vehicle that you can take is a flight, because even if I give you a Ferrari, which is the best car, you can go only all the way up to Miami. After that, your car will sink in the Atlantic Ocean, until unless you have a special car by of James Bond, which can become like a submarine and go through. But in normal cases, the flight is the best vehicle which can take you there. Now, in the real experimental condition, these are the parameters which you might consider. Just like here, the time and the resource, same way you have to consider in your sample whether your sample is dead or alive, what kind of stain are you doing, is it fluorescent label or is it like a standard eosin kind of a stain, what kind of sample thickness is it very thick sample or is it like a thin sample, what kind of field of view do you want to image the entire mouse brain or are you looking forward towards imaging inside a single cell, what kind of imaging speed do you want, do you have all the time it's a fixed sample or is it like a live moving sample and you want to image rapidly, what kind of optical resolution do you want, are you happy with a macroscopic image of a whole cell or do you want a subcellular compartment level of resolution, do you want to do a qualitative imaging just to show the features or do you want to do some quantitative data analysis through those images. Depending upon these parameters, you have to decide which kind of microscope do you use. Here is a flowchart which I have made for you so that you can make a decision easily. If it's a fixed sample, then see whether it's a fluorescently labeled sample or is it IHC. IHC meaning it's like a eosin kind of a stain which is like a fixed sample and can be a very thin sample as well. If you are trying to image near the surface, then TIRF is the way to go, total internal reflection fluorescence microscopy. Or if you are trying to do some kind of a single molecule analysis, this is the best workhorse for you. If you are trying to do a thin sample meaning it's like within 100 microns, then slide scanner or a confocal microscope or a spinning disk, depending upon the kind of need, you can use it. Slide scanner is good for doing a lot of bulk scale imaging that we'll talk about in the coming part of this slide. Confocal gives you a lot of flexibility and adaptability, but is also equally complex, hence takes a lot of time. Spinning disk microscope is less flexible compared to confocal microscope, but gives you a high speed imaging capability. Lastly, if your sample is thick and doesn't allow the light to pass through, in that case confocal microscope is good solution if you are trying to image within 100 microns. If you are going deeper than 100 microns, at max you can go 8 millimeters deep using a multiphoton microscope. For IHC sample, if it is a high data volume data set, in that case slide scanner is the best option because it can automate the entire process of data acquisition as well as data handling. Lastly, if you have a requirement of doing a high resolution imaging like we discussed before, confocal is the way to go. On the other hand, if you have a live sample like a cell which is supposed to be maintained at 37 degrees Celsius, in that case if you are imaging at surface, then TIRF is the way to go. On the other hand, if you are imaging inside the cell or inside the tissue, then confocal or a spinning disk can be used. TIRF can also be modified to image somewhat deep inside the cell by converting that into a highly inclined laminated optical sheet microscopy. You can have a special discussion with me if you want to do that. And lastly, if you are imaging inside the brain of the mouse or paw of the mouse or anywhere else, depending upon how deep you want to go, then multiphoton microscope is the best way to do. And lastly, if there is something which I have not covered here and you are still wondering which one to use, what to do, what not to do, in that case I am always there as a help that we can discuss and make things happen. This is the typical workflow that we follow if you want to come on board and start using the equipment. We do a free consultation for you. You can bring your sample, you can bring the research papers that you want to use as a starting point to get to the end result. Once the consultation is done and we have decided which microscope is the best one to use, in that case we can go for a test drive. Meaning you bring the sample, you put it on the microscope and we work together towards seeing whether the equipment is good enough for the result that you want to accomplish? And is it worth for you to get trained on the microscope at all? If you already know what kind of sample and what kind of microscope do you want to use, you can skip stage 1. Next, once you are sure that okay, this is the microscope that you are going to use, then send us a request via email that okay, you want to get trained on the microscope. Once that is done, we'll train you and we'll help you understand the basic dynamics of the microscope as well as the software, how to use it, what to do, what not to do, everything in detail. There are a lot of resources on the website as well, which will give you a better idea even after the training is done, so that you can always look back and get answers to a few questions which we would not have discussed during our training. Then we can go for a test run where you will be imaging and I will be looking at whether everything is fine and you are comfortable using the software without glitches, and overall microscope is functioning properly in accordance to what you want. And if everything is fine, then we hand over the keys and it's up to you how you want to run the microscope, and make sure that of course during the training process you will be trained on what to do and what not to do, but with the right training you can rock the world. And of course we are always there at the back end in case you need any support, as the imaging core facility is up here in the facility so that we can take care of you. With that, we come to the end of module number 1. In module number 2, we'll be discussing about what are the possibilities by which you can improve the kind of imaging that you are doing or the kind of data analysis that you are doing, so that you can save a lot of time and effort and make the best use of the equipment. With that, see you in module number 2.